All right, want to do a quick review here of population. So this is Unit 2A. 2B is going to be migration. So let's look at the big ideas, the models and the concepts in population. And looking back over this, there is a lot in here to cover. So the big ideas in here, we'll talk about density and the different kinds of density. We'll talk about one of the most important things we've talked about all year, the demographic transition model, and I can almost guarantee you that in some way, shape, or form, in one of those two FRQs, you're going to have something related to the DTM. Also related to that, the epidemiological transition model. We'll talk about population patterns. We'll talk about those great diagrams, population pyramids, what they can tell us, what types we might see in different countries. We'll talk about Thomas Malthus and the Neo-Malthusians and their current beliefs about the Earth's population and the carrying capacity, and then population policies to either encourage an increase in the population or to try to control an increase in the population. First, let's look at ecumene. Remember, ecumene is the portion of the Earth that is open or able to support permanent human settlement. And obviously that has changed significantly throughout history, as you can see there in the chart to the right. In current times, it covers most of the world's land areas, with the exception of the extremes closer to the poles. Population density, there are three types that we look at. The first is arithmetic density, and that's just going to be the total number of people divided by a unit of measurement of the land. So enables a comparison of the number of people trying to live in a given space in different regions of the world. So again, just pure and simple number of people divided by the total land. Physiological density gets a little bit deeper. It's the number of people that are supported by a unit of arable land. So again, it's a little more significant number because we're looking at an additional factor. And then the third, agricultural density. So the ratio of the number of farmers to the amount of arable land. And remember, that's going to be different, maybe a little bit counterintuitive if you think about a place that's developed and has fewer numbers of farmers producing a whole lot of food. So again, in the U.S., agricultural density is going to be very different from those in sub-Saharan Africa. So here's arithmetic density. And again, you can see those parts of the world where the population is much more dense, over there in Bangladesh, certainly in China, a couple places in South Asia. Physiological density, similar patterns, sub-Saharan Africa, East Asia, South Asia, certainly Southeast Asia as well. And then agricultural density, and again, you can see in those places where there's a lot of subsistence agriculture, East Asia, South Asia, Southeast Asia, sub-Saharan Africa, there are a lot of farmers, but in a place that's significantly populated, but more developed, fewer farmers are required. The ratio was below 25, for example, there in the United States. All right, just some look at curves. You'll hear references to J-curve and S-curve. A J-curve is going to be where you have population growth that's exponential, and we see that in the global population as we move into the Industrial Revolution. As population grows exponentially, so will our use and the demand on the resources that are available. An S-curve would trace more cyclical movement, updates and downward movement in the graph. For example, a population crash, as you can see to the right. Think about the Black Death and the dip that would put in the population line. All right, components of population growth, the demographic transition model, and we'll look at that more closely in the next slides. But first, some acronyms that we need to make sure we understand to measure population change. CBR, the crude birth rate, total number of live births in a year for every 1,000 people. CDR, crude death rate, total number of deaths in a year for every 1,000 people. The rate of natural increase, RNI, or natural increase rate, the percentage by which the population grows in a given year. Related to that's going to be the doubling time. So the number of years needed to double the population. And again, that's going to assume all other conditions are equal. So doubling time isn't necessarily going to be something that's going to be consistent going forward. It's just a snapshot of conditions at a given time. Total fertility rate, TFR, the number of children, the average number of children a woman will have in her childbearing years. All right, so here's the demographic transition model. We talked about the 4 stages, and then that 5th stage that is beginning to emerge as we see some countries enter the post-4th stage. So some of the characteristics, and again, I'm not going to spend a lot of time on it because it should be fairly clear to you at this point. But again, stage 1, high birth rate, high death rate as well. Very low natural increase rate, so population's not going to grow because birth and death pretty much cancels out. Second stage, you still have the high birth rate. You have a significantly rapid declining death rate, just with some basic introduction of sanitation, immunizations, and the like. So your death rate's declining. It's going to result in a very significant increase in your population, so a high natural increase rate. Stage 3, as we get into industrialization, you're going to have a continued decline of the death rate, a very rapid decline of the birth rate as more opportunities are available for women, other options, less of a need to have more children to work in the fields, that sort of thing. We start to see a leveling off or a moderation of the natural increase rate. And then stage 4, continued low birth rate, very low death rates, really no natural increase rate, but possibly as we move into the end of stage 4 into stage 5, a declining natural increase rate. So think about, and we talked about it, you should have examples in your notes of what countries might fall into these stages. And again, we'll look at, if you remember the map that we did, which you should have in your notes for each of these stages, we did draw a sample population pyramid, and you should look at those notes again. So crude birth rate, again, as you can imagine, sub-Saharan Africa, very high number of live births per 1,000, still seeing a little bit of that in South Asia. In the developed world, a much lower CBR. Life expectancy, again, in developed countries, going to be significantly higher. Those semi-peripheral countries, Middle East, Russia, and there's an example, East Asia, Southeast Asia, going to be in that 60 to 74 range, and then parts of struggling sub-Saharan Africa, 44 or less. AIDS has a big impact on that one as well. Again, the rate of natural increase, and this is on a global scale, so you can see from 1950 as the population grows, we had that sort of population bomb in the 1960s and this great concern about too many people in the world. You can see the annual increase started to slow down once we get to the mid-60s and 1970 and on, and the rate of natural increase is declining to the point where we should see in the next generation a beginning of a leveling off. When we look at population growth through history, remember it's going to be relatively steady. It takes a long time to double the population until we get to the Industrial Revolution, and that's going to change the whole ballgame. And we see that J curve, that exponential population growth. And again, thinking about that S curve, you can see the dip there for the Black Death. Related to the demographic transition model, we've got the epidemiological transition model from the early 70s. And basically this tracks vulnerability to disease in patterns that are similar to the demographic transition model. So in stage 1, going to be more susceptible to famines, pestilence, diseases like the Black Plague that's going to impact a large, significant portion of the population. Stage 2, we start to see a little bit more development. We do still have some more mass illnesses. Stage 3, as we're industrialized, we get more of the chronic disorders, things that might become more common as the population ages. And then stage 4, we continue to see that sort of the old people's diseases, arthritis and heart disease and things like that. Population patterns. And as we look at the global map, we can see that areas of high and low population density are really spread unevenly across the world. Most of those places that have high population density are going to be above the equator, so in the northern hemisphere. All right, related population pyramids. Again, those wonderful things that show the percentages of each age group in the total population and divided by gender. And remember, we can learn so much about a country based on its population pyramid. Poor countries tend to have a pyramid or a chart that is shaped more like a pyramid with a wide base. High infant mortality rates in those less developed countries. Life expectancy is much shorter, so it's going to narrow pretty quickly as it goes up the age groups. Again, a lot of information to be derived from a population pyramid. Percent in people and as a percent of men. Percent in people and a percentage of women. Population by age group every 5 years or docile. Population of men and women by age group. So how do we read a population pyramid? Well, first we determine if the pyramid's measuring the population in millions or as a percent of the entire population. And you should look closely at a population pyramid to make that determination, to make sure you're using the right terminology. Second, look at the question that you're being asked. Is the question that you're being asked about men or about women, or is it about the total population? Is it about a specific age group? Is it about certain age groups that are lumped together? And we'll see some of those logical lumpings here in just a moment. Look at also what you can infer from the pyramid. You can generally tell by the shape of the pyramid the level of development and maybe even what stage of the DTM that country is in. You can oftentimes identify significant events in a country's history. So remember when we looked at Russia, and you can still see the impact of World War II on the male population in Russia, because there's many fewer men at that upper age deciles than there are women. You can also see the impact of the baby boom, so you can see a spike in population. Interestingly, many say with the quarantine that we're going through now in 9 months, we might see a spike or a jump in the birth rate. We'll see if that plays out. But that would eventually be reflected in a population pyramid. Again, developing countries, states tend to have a triangular shape, low life expectancy, so they might even be a little squatty in their pyramid, a steady percent in each age dying off, so getting smaller as it goes up, and a very wide base with a high birth rate. In developed countries, it's going to be much more blocky, so you're not going to have a significant decrease in age groups until you get to about 60, and then as the number of the percentage of the population in the higher years begins to decline, you'll see it sort of come to some kind of point. Those countries that are in between, the semi-periphery countries, the middle income states, tend to have some elements of both of these. All right, other components of population pyramids, the replacement rate, total fertility rate at which girls would have an average of exactly one daughter over their lifetimes. So this is basically the replacement total. And remember, we talked about that being 2.1 because you have to have a daughter in order to continue to have in the next generation kids. So 2.1 again is that replacement rate. Another grouping that is logical you often see is the dependency ratio. So for dependents, you're going to look at those age 0 to 14 and those over the age of 65. You're going to take the numbers or the percentages in those two groups as a percent of the total population. That's going to be your dependency ratio. The demographic equation, one thing to remember is the demographic transition model does not account for immigration. So it's looking at the population. It's not necessarily looking at immigration over time. A population pyramid certainly could include all people present in that state. So think about the amount of immigration into that demographic area. And again, the sex ratio, the ratio of males to females in a population. And you'll see the impact in antinatalist policies. The one-child policy comes to mind, where you're going to have a higher percentage of boys than girls. So that's going to be a factor that you could be asked to address as well. All right, Thomas Malthus, the gloomy parson, if you remember, very influential in the fields of political economy and certainly demography. His famous essay is the essay on the principle of population. And basically his premise is there on the right. It's that population grows exponentially, and it certainly did, where the food supply grows, or ability to produce food grows arithmetically. So that was his belief, and eventually we would come to this point where we would have a greater population than we can produce food to feed. So we would have a crash at that point. So that was Malthus' belief. He believed that we would reach that carrying capacity, so that ability where we wouldn't be able to support them. So in general carrying capacity, the size that the environment can sustain indefinitely given the food, habitat, water, and other necessities available for the environment. So even though Malthus' theories proved, thankfully, to be incorrect, because we were able to, with human ingenuity, increase our food production, there are still neo-Malthusians around that advocate for significant population control programs to make sure that we have enough resources for those present and those coming in the future. One that challenged Malthus' confusion and continues to are the ideas of Boserup. Basically said that food production can and will increase. One argument is the cornucopia, if you remember, where the more people we have, the greater our ability to come up with innovative and more productive methods to produce food. Malthus' critics, Boserup included, believed that he was too pessimistic, a theory based on that the world's supply of resources are fixed rather than expanding. And again, think about that cornucopia effect. With more human beings, there's more ingenuity, more creativity. We're going to come up with innovative ways to produce more. Some disagree that population increase is not a problem. Larger populations can stimulate economic growth. Again, we can create more economic growth, more resources, and feed a population. All right, population policies, and this was a fun aspect of population, if you remember. We have expansive population policies, which we called pronatalist, encouraging population growth. We talked a little bit about selective population growth, so eugenics, favoring one cultural sector or ethnicity over others. And then we talked about antinatalist policies, or restrictive population policies, where they're trying to limit or control population growth through government programs, through other aspects coming from the state or coming from other political or cultural influencers. More specifically, pronatalist policies, expansive policies, Sweden and Norway, state policies to encourage people to have more children. We also talked about Hungary encouraging its population to reproduce, whether they give them tax breaks or cash payments or baby supplies, things like that. We also talked about Singapore, and we talked about Denmark, doing it for Denmark. And I can't remember, Singapore, I believe, was Mentos Night. So those were fun, but basically trying to encourage the population to reproduce. When we talk about eugenics, although eugenics philosophy was developed in the U.S., we saw it manifest most dramatically in the Nazi regime in Europe, with selective sterilization and encouragement of producing the Aryan race. Restrictive policies, the two main ones we talked about were China and India. China with the one-child policy, restricting the number of children that urban couples could have. It was a challenge certainly for the Chinese to enforce that, especially in the countryside, but it did have a significant impact on the population of the country. It encouraged the selective abortion of female fetuses. So you do have one of the impact being a significantly greater number of males in the population than females. In India as well, we saw discouragement for reproduction coming from family planning programs, and in some cases, the government forcibly sterilized certain elements of the population so they wouldn't reproduce. All right, influence of health and well-being, closely related to the location and the geography of the state. Infectious diseases have an impact on health and well-being as well. The invasion of parasites and how they multiply in the body. We didn't talk a lot about vectored and non-vectored, but this pretty much makes sense. Malaria being a vector disease that is transmitted by an intermediary vector, in this case the mosquito, so that's going to be dependent upon geography. AIDS, a non-vectored disease, which comes from direct contact between the host and the victim. Chronic and degenerative diseases, again, something we're going to see more in developed countries as the population ages, things like heart disease, cancer, stroke, pneumonia, diabetes, partially coming from diet as well. And then genetic and inherited diseases that make it from one generation to the next. And then metabolic diseases, lactose intolerance, and the like. So again, the impact of disease on health and well-being, somewhat related to the physical location of the state and the population, somewhat related to where they are in the development process, to the ability of generations to pass things down to. All right, so that is our summary, our review of population. After this, we'll move on to migration.